Okay, we're in the Python language, and we're going to try to build a program that encrypts words using the Caesar Cipher Cryptosystem. Okay, so we've reviewed a lot of things, so there's quite a bit of background knowledge we need for this. There was a diagram we had built out, and this diagram is to help us set up our steps. So the first step in our diagram was to get input from our user. What is the message? Okay, so in order to do this, we're going to define our own message here. So we're going to create our own function. We're going to call it get message. Okay, set up our colon, and we want the program to print enter your message. Okay, we may put a colon there. Great. And then we want the program to return the input of the user, which is important. Okay, so this function gets the information from the user. So we've defined our first one. The next step in the diagram was actually to also get the value for the key for the Caesar cipher. So they need to give us a number. Are we shifting the letters by 2, by 3, by 5, by 15, by 90, which is far larger than our alphabet, so it actually have to wrap around. But we're going to also define that. So we'll call it the cipher. Get cipher value. Okay. We set up our colon, and we were going to say print enter the cipher key. There we go. And same concept, we need to return the input of the user. Okay, so both of these functions, okay, get message and get cipher value, they ask a question and they get something in return. Okay, so what we want to do is we want to get the original message. So I'm going to give it a variable. Message is equal to the function we've made called get message. Get message. There we go. It has it nicely for us. So this program, just to start, we'll do a little run and check. We run it. Enter your message. Hello. Let's just leave it with hello. Great. That's all this program does. Okay. The next thing we want to do is we want to figure out what the key is. So we're going to say key is equal to get cipher. So that's our made function. Now there's a little bit of a problem. We'll get to it in a second. Let's run this here. Enter your message. Hello. Get cipher. It didn't like get cipher value. It'd be nice if I said input. There we go. Let's try that again. Sorry, I spelled input incorrectly. Hello. And historically, the Caesar cipher was a 3. So hello, there we go, 3. So it's got that information, and now it's assigned the variable message, hello, or whatever the message, and the key, the number 3. Great. Now we need to do stuff with these, okay? So what we're going to do is we're going to do some encryption. So we're going to run a loop, and this loop is going to run through each of the letters in the message. So the message in this case is just the word hello. So we talked about a for loop. We're going to say for x in message, because we don't know what the message is. We have to give it the variable. We need to encrypt this. Okay, so for x in message, we're going to run an encryption. Okay, now this part is a little trickier. What we need to do is we need to kind of break it apart per character. So X is going to run through each of the characters in the message. So for instance, the word hello starts with a capital letter H. What we need to do is move that a certain number of values and then concatenate it back together. So what we're actually going to create is just before our original variables, I'm going to call this a variable called encryption. Okay. And it's actually going to be an empty string to start. Okay, and you'll see in a reason why. For x in message, so we're still tabbed in, we want encryption, that variable, to be equal to whatever was originally there. So to start off, encryption, which is an empty string, plus we want to add in our string here. So we're going to have to return this to a string. So actually, let's start off a little easier with this. The very first letter would be the letter H, okay? So what we need to do is we need to convert in the ASCII chart, or in the Unicode chart, I should say, we need to convert using the OR function the very first letter. So it would be X in this case, because remember, X runs through each of the letters that are in that message. So it's going to take X, okay? And what we want it to do is we want to just add the value of whatever the key is, because they're inputting our key. Okay. Now, what you're going to notice is we're going to run into an issue. We'll run this program real quickly. We'll say hello and 3, and bang, we run into a problem. And that's because we run into an issue with the types of variable and integer. In this case, we've converted it to integer, but then we've asked it to concatenate to a string. Okay. I need this to go back to a string. Okay. So we need to figure out what that value is as a string. So in order to figure that out, so this is going to give us some number here, okay? So actually, let's just, now I remember. I'm looking down here thinking I've made my errors, but my error is in key here. Key, at the moment, is in string. I need it to be an integer. So I'm actually going to run the built-in function integer, okay? My problem was I was assuming key was already an integer, but it's not. So the user is going to input it as a string. So when I put in the number 3, the computer reads this as a string. I'm going to change it to an integer so that when we run the OR function with the letter X, that becomes a numeric value, and this is a numeric value. It will add the integers together. It will then put it back as a character, and it'll add it to our encryption. So let's say hello 3. Program to run, but what I finally need it to do is I need the program to actually print our variable called encryption. Okay, so let's run this program. Let's say hello 3. There we go. We've got it to actually run here. So we've built this. We have our 2 main functions. We start it with an empty string. We get an input from the user, which is a string. We convert it to an integer. This allows us to use the OR function on each of the letters of the message. It changes them to numeric values. In fact, I'm not sure I actually need this string at the end here. Let me double check. I may not need that because I think it's going to be a string at that point. Let me double check though. It is. Yeah, I didn't even need that part because the CHR converts that numeric value to a character. And what it's doing is it's looping through this. So for the H, it moves it 3, then it moves the E3, the 2 L's 3, and the O3, and it gives up the encryption KHOOR. Okay. Now, if we want to get a little fancier with this, we can use some conditional statements to make sure that we don't run into the problem of looping over. For instance, if we run this program and we say hello 27, let's say. Oh, sorry, I didn't need the numbers. Actually, I wanted the key to be 27. You'll notice that I'm kind of outside of our letters here. Actually, I wanted to run it with just letters. We'll say XYZ. And we go 3 and up with 3 symbols. Where really we probably want that to loop back around. If we just want the to run through all the Unicode decimal values, that's fine with what we have. But we can build some if statements in here. Okay, and we can say if the numeric value of the first letter in the message plus the key is greater than, and we've got to look up our ASCII table, greater than, what's the last value? For the last lowercase value happens to be 122. So if it is greater than 122, okay, what we're going to do is we're going to get this encryption. We have to indent it. We'll get this encryption, and we're just going to we're going to take this, and we need to actually subtract by a value here. Subtract by 26, okay? I need to put this bracket here before we actually change it into a character. Okay, so I kept it in this set of brackets because at this point it's still numeric, it's still an integer. So it's going to go over, and I'm going to subtract by 26 in this case. Okay, so we'll run it there, and then we have our if else. Else what we want is we want the exact same encryption algorithm, but we don't want the minus 26. We don't actually need that. Okay, that extra set of brackets we can drop off. Okay, so now let's try running this. Oh, main value, key 20. If is this, oh, don't forget your colons. And this one needs to line up. So Python's a language where you got to make sure your indents are actually all the same. Oh, expected in the indent block. Oh yeah, sorry, I literally said it out loud and I didn't even abide by what I said. There we go. Let's say X, Y, Z. We want a key of 3. There we go. We've got it to loop back around. But if we take a look at the ASCII table, there's actually a couple holes in this table. I mean, when we get to the lowercase, that works out perfect because when we get down here, it's always going to loop back around, okay? Assuming we don't use a value greater than 26. We might have to use the modulo to actually fix that up too. But we also have our uppercase letters, and you'll notice between the uppercase letters, we get some symbols here. So we kind of want to correct for that also. Okay, so let's actually go back in our testing space, and let's add an extra one in there. We'll use the elif the ordinate, the value of x is, let's say, greater than, and we'll check out our table here. If it's greater than, where's our uppercase end? 90. So if it's greater than 90, okay, we're going to come back down and we're going to use the encryption that we have here. Same concept, exact same thing we have before. So we're going to be using uppercase letters in that case. So when we go to run this, let's use X, Y, Z and letters X, Y, Z. So we did uppercase and lowercase, and we'll get it to move, oh, we'll say 4 this time. We jump back around. Oh, our uppercase did not work out. Why didn't it work out in this case? And that's because your X, Y, Z ended up being greater than 90. Oh, I'm so sorry. I meant plus the key. We need that. There we go. I found my little error there. Let's try that again. X, Y, Z, X, Y, Z. And let's say we move 4 this time. There we go. It's looped back around. Sorry, I forgot to put the addition of the key in there, right? Because the original values wouldn't have been greater than 90. But when we add the key to it, it puts the decimal values larger than 90. Okay, so there we go. We have our kind of encryption. If they were to happen to put something larger than 26, we could tell them, you know, please don't do that. But we can build something in to actually check for that. In our key, we can actually use a modulo. And if we just very nicely put a % 26 at the end. Now when we go to run this program, let's use that XYZ again, and XYZ. Let's say they did something like 3, but 3 past 26 would be 29, okay? So this, if we use the modulo correctly, should give us the remainder of 3, so we should get the exact same thing we had last time, which is exactly it, ABC and ABC again. That modulo corrects for cipher keys larger than 26. So you could do that. It's a mathematical way of using the modulo to help you in this case. But otherwise, you could also just put it in a parameter that they must enter a number between, 1 and 26. That's another potential option.